let's get the input for our window. Last video, we opened the window, and today we'll slowly start to turn it into a game. Stay till the end because there are some weird pitfalls that I have to explain. Let's go. So, when you have a window, you can't use the getAsyncKeyState function that I have shown in day 1. You want to only capture the input that is meant for your window. That means when your window has focus. getAsyncKeyState captures the key presses globally. Using events also has the advantage that we get all of them in order. Plus, we can't lose any button press. So, we have to use the event system that I have talked about in the last video. Windows will simply give you an event when keys are pressed or released here. Now we get into the problem. So imagine you are writing the game code here and you receive the input in another function, or possibly more functions. Trust me, writing the logic in this way is an impossible mess. Window APIs use events because it makes sense for them, so the API is good. They must have seen my video on API design. But we want to abstract the input so it is easier for us to write the gameplay code. I'm looking at you, Qt, or people that write their code like this. So we want to have what I call immediate input. Basically, we'll have a way to ask for our framework at any time if a key is pressed, held or released. Pressed is true only in the first frame we press the key, released in the last frame, and held every frame the key is, well, held. We'll add some other flags later. This pattern works very well for the game development, and not only. Like, look at it. We can get more easy to read, understand and maintain like this. There's only one more thing I want to say, and it is the fact that I like to take a data-oriented design approach for making things like this. Let me show you how the input in my engine looks. I hold the input into a struct, and I will just pass it to the user later. Accessing it looks like this. The other option would be to hold it globally and access it something like this. This is similar to how you access functionality in Unity. Now you should avoid global stuff in general, but my version actually has some actual advantages. For one, it is easy to see what systems request to use the input. A system that doesn't need the input can be moved to another thread easily, for example. Also, it allows you to implement code reloading or input playback. Think about it. Your game is a simulation. If you hold all of your game state info in a struct and the input in another, you can easily save the game state and the input for every frame you want to record, and then play that input back. You can even make a system to automatically play and test your game. All of this is possible because of this struct and data-oriented design. So, starting from day 11, I added two new files, input.cpp and input.h. Don't forget to also add them in the CMake. So I'll first create the button struct that represents one button. It has these flags for now, and we'll have to set them correctly every frame, and read them in the gameplay code. I'll talk about separating the window code from the gameplay code later. The input code will have an array of buttons. I'll also define an enum in the button struct. The idea is to access the input like this in the gameplay code. I wanted the buttons to be behind the name button. You don't have to write them by hand. You can just take this from my GitHub in this tutorial's repo. So this enum is just an index into the array for every button. Also, notice the buttons underscore count. That is just, well, the number of buttons that you have in the array. Okay, let's add the input in the Windows stuff struct. Now let's start getting the input. We have to do this inside the windproc function. Remember, this is where Windows will send us the messages, and these are the messages that we need to look at. Windows tells us every time a button is pressed or released. I just created a boolean flag, and it will be true if the button is pressed, or false if it is released. Now Windows will give us a button code for each key press into this parameter. The button codes look like this, so we need a way to convert that key into an index inside our array. And this is how it looks. Again, you can take it from GitHub. Notice that the keys are in the exact same order as the ones in the enum. You'll need to have C++17 enabled to use the context per static member, but you can just move the struct in the CPP file like so, if you don't know how to enable C++17. Also, since we are using Windows defines, don't forget to include Windows.h here. Okay, now we need to search for the correct key and update it. It's not ideal that we are searching them like this instead of using a map, but it really isn't a performance problem. and it makes the code much simpler. Feel free to change it later, but again, it really doesn't matter for such a small number of iterations. I created a function called processEventButton in Input.h that will process the button press. It takes a button by reference and a flag that is true if the button is pressed and false if it is released. The code is simple. If the button is pressed, we just set the pressed and held flags to true and release to false. And if the button is released, well, we'll do the opposite, setting every flag. Now we are not ready yet. This correctly sets the held flag, but the pressed and released flags need to be true only for one frame. So let's go down where we update the window. This is where we get the input. Here we'll eventually run the game. Let's add some codes to reset all buttons after the current frame. This function looks like this. We just reset the pressed and released flags, leaving the held flag on. So we got the input, we did something with it for one frame, and finally we reset it. Okay, now inside where the gameplay will run, let's print some values to test if the code works. The held button works fine. Now let's test the pressed and released buttons. They seem to work at first glance, but look what happens if I keep holding a button. After a few moments, I keep getting pressed messages. What's going on? Well, think about typing. When you press a key, it will be registered once, and then after a few moments, it will be registered again at a fast pace. This is useful, but for now it breaks our logic. Fixing it is simple, however. Inside process button, we set the new state only if the button is unheld already. This fixes the problem, but now we still have some other problems unsolved. What happens if we never receive the released message? Could that happen? Think about it for a second. Well, actually yes. If I hold the key down and then switch to another window, the first one won't receive the released event, leading to results like this. I'm not pressing the button right now, but the window is simply waiting for the released event. Fixing that is also easy, fortunately. We just need to look at the focus of the window. This just means if the window is the current window used by the user. So let's do that now. I'll add this flag inside the input because they are related, so we can pass them together like this to other functions later. Okay, so these are the two events that we have to look at. WM_setFocus and WM_killFocus. Here I'll just set the focus accordingly. Finally, if the window is not focused, I'll just reset the input after I get the input update. The reset input function looks like this. Don't worry, zero memory is just a define over memset. I'm just clearing this array. Okay, now let's test the focus and the buttons. Everything works fine now. Now I split the input tutorial in two parts, because as you saw, there are many things and I wanted to keep it simple. So next time, we'll also do what I call typed input, cursor input, and probably other small things. If you find these tutorials hard and want to level up easier, you can 1. Join my Discord to ask me questions directly, and 2. Share this tutorial series with an accountability partner. You'll both help each other stay on track with the learning and get to the next level with your low level coding. And you will also help me. So, see you next time.